Hello everybody. As we move on to 2-6, I really want to start the lesson by telling you if you understand 2-6 now, a lot of the other chapters are going to make much more sense to you when we get to them. So please take the time to understand moving functions around now. You can believe me now, or you can believe me when it's almost too late. So get to know it now, that way when we do it later, you're not struggling. Okay, so a parent function, that's our first definition today. A parent function is what we call the simplest form in a set of functions that form a family. Like, for example, there is the straight linear family, there is the parabola quadratic family, there's the cubic family, and there's the quartic family, and so on and so forth. So when we continue on to these, make sure that you understand each family is a set. You have the absolute value. Each graph has its own family. The transformations that's how the function, it is how it is different from the parent function. In other words, what transformations did this straight line take? Did it move up? Did it move down? Did it move left? Did it move right? A translation is what I call a move or a shift of the graph up or down. A reflection is a flip of the graph. So ready? If this is my hand, this is a reflection. Okay, so it would be like taking this and flipping it over. That is a reflection. A translation would be moving it up or moving it to the right. Okay? So this is a reflection, this is a transformation. Now a vertical stretch is when you multiply all of the y values of a function by the same factor. Now that factor needs to be greater than 1, okay? Greater than 1, and I mean its absolute value is greater than 1. Now what would that be an example of? That would be an example of something like this. Ready? If you have like a circle and you vertically stretch it. Something like that, when it gets stretched. You'll see what I mean as we continue on. We're going to talk about stretching parabolas. An example, if you want to see one, would be like, let's say we have a shape like this. A vertical stretch will be something like this. Okay? The last thing we have is a vertical compression. It is when you multiply all the y values of a function by the same factor. That factor has to be between 0 and 1, like 1/3 or 1/2 or 0.1 or 0.2. Now what that would do to a parabola is it would take that parabola and it would look like somebody actually stepped on it. Okay? So that's the difference. Vertical stretch, you kind of narrow it up, and a vertical compression looks like it's been stepped on. We may do this in class, we may not, but let's save it for when we come together. Look at the bottom for the word translation. Can you please title this section Translation? All right. So let's say that we have this is the original. The middle one's the original. If you have an original function, okay, this one just happens to be, it's actually like a sine or cosine graph. You'll learn about that later. But let's say you just have some type of graph. A vertical translation is when you add k to it. Okay, so the top one is plus a value. You would just move it up. The bottom one is when you would minus a value, when you would like minus a k. Alright, so you can move up and down. Now let's say we have a parabola. This one here, this one's the original. You can also move something left and right. Now to move it left and right, the value of x has to be changed, okay? Again, you might want to write that down. To move it left or right, the value of x must be changed. To move it up and down, the value of y must be changed. Now I got to give you some examples, because this might not make a lot of sense to you. Let's talk about moving things up and down, okay? Let's pretend that we have the equation y equals 2x, okay? Let's say that that is the original equation. If that's the original equation, then y equals 2x plus 1 would move it up 1 unit. And if we have y equals 2x minus 1, that would move it down 1 unit. So I hope that that's pretty straightforward to you. Up and down is when it's kind of in the back, okay? I'm going to talk to you about left and right now, and I'm going to do that with a parabola. Let's say that we have y equals x squared as the original. All right? I want to show you how to move it to the, let's talk about how to move it to the left first. Well, you're going to have to change the value of x and then square it. To move it to the left, and this is going to sound weird to you, but to move it to the left, you would actually have to add a value. In this case, this would be moved to the left 1 unit. Now, if you had y equal the quantity x minus 1 quantity squared, that would move it to the right 1 unit. So now you have some examples about what it looks like when it's moved up and down and what it looks like when it's moved left and right. I should probably give you one more example and ask you what you think it is. Okay? One more extra example would be, and now let's see how well you do. If you have y equals x squared plus 4, how do you think that would move? Well, since the 4's in the back, it's not with x. That means this one would move up 4 units. Okay? I just wanted to make sure that you saw the difference. It has to be with x in order to move. Moving on to problem 1, we're going to talk about vertical translation. So let's say that we have the function y equals x, and then we have the function that y equals x minus 2. How are their graphs related? I'm going to break this up. I'm going to answer this question first. Can you see how it's minus 2 in the back? Since it's minus 2 in the back, you're going to say that it goes down 2 units. And we're going to use our real words, and we're going to use, that should say translated. It's going to go translated down 2 units. Now let's go ahead and graph these the way that we know how to graph them. The y-intercept in the first one is 0. And the slope, well, you should know, first of all, that this is a straight line. Maybe I should have identified that first. You should recognize these as straight lines when you graph them, which means right away you find b and m. Alright, so your y-intercept is 0 and your slope is 1 over 1. Okay, let's graph that one first. Here's 0, 0, that's your y-intercept, and the slope was up 1 over 1, up 1 over 1, up 1 over 1, so on and so forth. Graph them with a straight line. Now if you have 2 different colors, that might be helpful for you at home. I'm going to get a colored pencil so you can see the difference of the other one. Alright, now let's graph this one. The b this time is negative 2. The slope remains 1 over 1. So let's graph it. Go down 2, up 1 over 1, up 1 over 1, up 1 over 1. So you can see that they are parallel lines, right? But you should notice that the orange line has been moved down 2 units. Translated down 2 units. Alright, let's talk about part B. What is the graph of y equals x squared minus 1 translated up 5 units? Well, if I need to move this thing up 5, I'm going to write add 5 at the end. So I'll do x squared minus 1 plus 5. So that would be x squared plus 4. Okay? And that's all there is to it. This is the translation up 5. Now, how do you graph parabolas? That maybe you need some review on from Algebra 1. You make an XY chart, and I like to pick my values negative 2, negative 1, 0, 1, and 2. Alright? And I like to plug those in. So I would do negative 2 squared, and then I would add 4. That will give me 8. And then I'll do negative 1 squared, add 4, and that will give me 5. 0 squared, add 4, gives me 4. 1 squared plus 4 gives me 5. Look at the reflection. That's what parabolas do. I don't know how well you remember them. 2 squared plus 4 gives me 8. See this perfect reflection? That should always happen. So, All I need to do is graph my points. -2 up 1, 2, 3, 4, 5, 6, 7, 8. Over 1 up 1, 2, 3, 4, 5. Over 0 up 4, over 1 up 5, over 2 up 8. You have a perfect parabola. Now if I graph my graphing calculator, it might benefit you to see both of them graphed, and that's going to be easy to do on my graphing calculator to show you the difference. Okay, the first one, it was x squared minus 1, right? The second one we found was x squared plus 4. When I hit graph, look at them. There's the first one, there's the other one. You can see how it has just been shifted up 5 units. If you count them, you can see 1, 2, 3, 4, up 5 units. Okay? Let's take a look at the got it. How are the functions y equals 2x and y equals 2x minus 3 related? How are their graphs related? Well, you should notice that the only difference is this minus 3. And since that minus 3 is in the back, that means that that one has gone down 3 units. Otherwise, nothing else has changed. And since it's moving up and down, you can say that the y values are 3 down from the other one, because it's an up and down change. Let's look at our options. Each output is 3 more than. Nope, that's not right, because it's a minus 3. Each output of y equals 2x minus 3 is 3 more than. We can get rid of that again. Alright, let's take a look at this one. Each output for 2x minus 3 is 3 less than the corresponding. That's good. The graph of 2x minus 3 is the graph of 2x translated down 3 units. That's perfect. It goes down 3 units. This one has the same exact wording, except it had that tricky word that it moved to the right, which it did not move to the right. Moving on to problem 2. The graph shows the projected altitude. By the way, if you don't know what that word means, it means height. This graph shows the projected altitude of an airplane scheduled to depart the airplane at noon. The plane leaves 2 hours late. Let's go ahead and write that down. 2 hours late. What function represents this transformation? Okay, well, down here we can see that it's hours after noon. This one, the first graph, is the original. So I'm going to write that down. The first graph is the original. The second graph is the 2 hours late one. You should be able to see that this graph has moved how many hours? 1, 2. It has moved 2 to the right. Because it has moved 2 to the right, that means that I would take my original and I need to move it to the right. Well, what did I teach you is moving it to the right? Hopefully you remember that to move it to the right, you have to take x and you have to subtract 2. So this represents 2 hours late. Now I know a lot of people get a little confused with that because they think that minus 2 would be before. I tell them this. It's like you have to figure out what you would do to get back to the original time. So if you left 2 hours late, that means to get back to the original time, you'd have to take 2 away. Okay, so this is the translated late equation. Let's move on to the got it.